Right, so this is test D from chapter 2. First thing we're going to do, multi-choice. What does this simplify to? They're all like terms in this one. They're all like terms. So we've got 3y plus 7y is 10y. Take away 1, 9y. That one's pretty nice. The solution for this equation, so we perform inverse operations. So make sure you're following along. Don't do your own thing now or else you'll not keep up. So the first thing I've got to do is get rid of subtracting 6 by adding 6 to each side. So now I'm going to have 15x equals 30. And then what's the inverse operation of multiplying by 15? Dividing by 15. So you can do it with a division sign or by writing divided by like that, can't you? And 30 divided by 15 is 2. So you got your answer there. Now, some people are still getting a little worried about these greater than or equal to ones or less than or equal to ones. And they're the exact same thing as solving a normal equation. The only difference is if you multiply or divide by a negative, you turn the sign around. Otherwise, you just do what you would normally do for an equation. So here, I want to get my n's together. I've got more of them on the left, don't I? 9's bigger than 4. So I subtract the 4n. I get rid of it from the right-hand side. If I'm putting all of my letters on the left, what side do I want my numbers on? The other side. So the opposite of taking away 3 would be to add 3. And so we can then write our next line, 9n minus 4n, that's 5n. And that's greater than 2 plus 3 is 5. And now what are we going to do? Divide each side by 5. That one's pretty easy, isn't it? N is greater than 1 when I divide each side by 5. So it's just the same as solving a normal equation. If you never multiply or divide by a negative, it's exactly the same. 6x plus 2y equals 36 and y equals 6x. The solution for x when solving these two equations by substitution. So we've got our two equations. Which one are we going to substitute into the other one? Anyone? Which one is already rearranged so that it's y equals something or x equals something? Isn't it equation 2? Equation 2's got y equals 6x. So all I'm going to do is say, let y equals 6x in the first equation. So what does my first equation become? It's 6x plus 2, and what do I write instead of y? Yeah, I write the 6x in there. So now we've just got to simplify this. 2 lots of 6x are 12x. So that's 18x equals 36. What do I do to get x on its own? Yeah, divide by 18. And that one's pretty easy, isn't it? X is going to equal 2. So again, you'll be able to go back and copy more of the working if you need to later on. Is that alright though? If you've got any questions, just stop me while we're going and we'll make sure we answer them along the way. The evaluate mean. What does evaluate mean? Yeah. You can see it's got value as part of the word, doesn't it? So the answer should be a number. So I should be able to reduce this to a number. The only thing you've got to be careful about when doing these ones is that if there's a negative number that you're substituting in, put it in brackets just to make sure you get it right. This one here, x squared, well, x is equal to 7. So this is going to be 7 squared plus 2 plus z is 4, y is 3, and we're going to have to cube that. So this is going to be a pretty big number. So we're going to have 49 plus 2 in that first bracket. What's 4 times 3? 12 in the second bracket. And now this is where it gets a bit more fun. 51 plus 12 to the power of 3. Yeah, well, 12 12s are 144, and then we've got to multiply that by 12. You won't get numbers that big if it's a non-calculator exam, so you don't need to worry about it. But I don't even know. You can ask your friends. I think so, but that just usually means the numbers are easier, so it's nicer for you. It should be non-calculator exam. That's what I would hope it is, because then all showing you working and everything's really going to help you. So anyway, when we do 12 to the power of 3, it's like 64. That sounds pretty good to me. 1728. And we add that together with the 51, and we get 1779. Answer E. Did other people agree when they went 12 cubed? Very good. Well, that's part A done. I'm going to stop that video there. And